NASA is hiding a shocking secret about the moon, one that could change everything. It's not just barren rocks and craters. The water there moves mysteriously, appearing and vanishing in an unexplainable cycle. Even stranger, it survives the moon's extreme heat and cold. What NASA found in the moon's shadows could redefine the future of space exploration. Scientists have been chasing lunar water for decades, and what they've found raises more questions than answers. Our lunar neighbor is not supposed to have water. Its surface is blasted by the sun, temperatures swing between scorching heat and freezing cold, and there's no atmosphere to keep water from escaping into space. Yet, water keeps showing up where it shouldn't be. But what lies beneath the moon's surface could change everything. Back in the 1970s, the Soviet Union sent Luna 24, a robotic probe, to the lunar surface. It drilled about 2 meters into the surface, grabbed some soil, and shipped it back to Earth. Scientists were shocked to find traces of water in those samples. About 0.1% of the material was water, and the deeper they went, the more water they found. But most experts shrugged it off, calling it contamination from Earth. Fast forward to the 1990s, and NASA's Clementine mission started looking closer. It scanned the satellite and found craters near the South Pole that had been in shadow for billions of years. These dark spots were so cold, around -173 degrees Celsius, that any water ice trapped inside could stay frozen forever. NASA wasn't about to leave things there. In 1998, the Lunar Prospector spacecraft scanned the poles and found huge amounts of hydrogen, possibly tied to water. The data hinted there could be up to 300 million tons of ice hidden in craters. But hydrogen alone doesn't prove water. It could just be hydroxyl, a chemical cousin to water. To get a clearer answer, NASA deliberately crashed Lunar Prospector into one of those craters, hoping to kick up ice. But nothing showed up. Japan tried a similar trick with its Selene spacecraft in 2007, and again, no water. But this discovery raised even more questions. Why didn't the water evaporate? Temperatures on the sunny side can hit 127 degrees Celsius, hot enough to fry electronics. Yet in the shadows, temperatures plunged to -240 degrees Celsius, colder than anything else we've measured in the solar system. But recent data shows the story is even stranger. The Lunar Reconnaissance Orbiter, LRO, found traces of water molecules scattered all over, not just in dark craters. Even weirder, this water seems to move. It disappears during the day and comes back at night, acting like it's part of some lunar water cycle. Scientists have theories, but no solid answers. One idea is that micrometeorites might be raining down on the surface, delivering tiny amounts of water each time they hit. Another theory points to the solar wind, which could be interacting with oxygen in the soil, creating water-like molecules. These molecules might then get trapped inside glassy beads formed by meteorite impacts. Whatever the explanation, this discovery changes everything about future missions. It means astronauts might not need to lug water all the way from Earth. Instead, they could set up mining operations to extract water directly from the lunar soil. One crater, measured by the LRO, hit temperatures as low as -250 degrees Celsius, the coldest spot ever recorded in the solar system. That kind of cold could shatter spacecraft and freeze machinery solid. But here's the catch. What if the water isn't as easy to access as we think? Some scientists worry that most of it might be locked away in tiny grains of soil, requiring complicated and expensive extraction methods. Others point out that the harsh environment might make long-term missions too risky. And then there are the conspiracy theories. Some believe NASA and other agencies already know more about lunar water than they're letting on. After all, if it holds enough water to support life, it could completely change how we see space exploration, and even raise questions about whether life might already exist out there. NASA has always been the go-to name for space exploration, but what if there's more than they're letting on? Let's just say things might be a lot stranger than they appear. Buckle up, because this isn't your average science lesson. This is about secrets hiding in plain sight and why everyone suddenly wants a piece of it. First off, parts are colder than Uranus, Neptune, and even Pluto. That's wild, right? Deep craters with edges sharp enough to block out sunlight have turned these spots into nature's own freezers. Scientists have long suspected these shadowed regions might be hoarding ice, but that's just the tip of the iceberg. Along with frozen water, they've found traces of carbon dioxide, carbon monoxide, nitrogen, and argon. Then things got even weirder. NASA's SOFIA telescope, a flying observatory, spotted water on sunlit parts. Wait, what? Yep, water where it has no business being. They zeroed in on Clavius crater, one of the biggest craters visible from Earth, and found water molecules scattered in concentrations as low as 100 to 400 parts per million. To put it in perspective, the Sahara Desert has about 100 times more water than the soil. So why does this matter? Water isn't just for drinking, it's space gold. It can be used to grow plants, sustain colonies, and, most importantly, fuel rockets. Splitting water into hydrogen and oxygen creates rocket propellant, and launching stuff is way cheaper than launching it from Earth. With only 1/6 of Earth's gravity, it's practically a space highway waiting to be built. With water and other useful compounds up for grabs, it's looking less like a barren rock and more like a shiny new frontier. China and Russia are already plotting missions to set up robotic bases near the South Pole by 2030. Meanwhile, NASA's Artemis program aims to send humans back to the surface for the first time since 1972, and they're not stopping there. They want a full-blown base. The moon's hidden resources could reshape our future. Let's talk about helium-3, one of the hottest commodities. If you've ever read sci-fi, you've probably heard of it. Helium-3 could fuel nuclear reactors without producing radiation or nasty waste. It's also handy for medical imaging and radiation detection, but there's a catch. Earth doesn't have much of it. Sure, you can find trace amounts in natural gas, but extracting it is pricey and inefficient. Alternatively, it can be made as a byproduct of nuclear weapons production. But let's be real. No one's itching to ramp up nuclear arms just to make reactor fuel. This leaves the lunar surface, where helium-3 has been piling up for billions of years, thanks to solar winds. Don't get too excited, though. Even there, it's rare. Around 50 parts per billion in the surface soil. Still, because it's spread out evenly across the surface, mining it alongside other materials could make the process worthwhile. China, the US, and even private companies are eyeing helium-3 as a future fuel source. If it works out, we're talking about clean, limitless energy, and that's a game changer. Helium-3 is just the beginning. Lunar soil, called regolith, is stuffed with metals like iron, titanium, aluminum, and magnesium. Breaking these down could also release oxygen and hydrogen, essential for breathing and fuel. Lunar regolith might even be turned into building materials like lunarcrete, cutting down on the need to haul supplies from Earth. And if that's not enough, it is hiding rare earth metals, those elements in your phone, laptop, and electric car. While they're not super rare on Earth, they're scattered thinly, making mining expensive and messy. It might hold easier to reach deposits, turning it into a gold mine for tech companies. With all these resources, the idea of a permanent base doesn't seem so crazy anymore. Picture this: a self-sustaining colony that grows its own food, mines its own fuel, and manufactures its own materials. Plants can even grow in lunar soil, although hydroponics might be the safer bet for large-scale farming. But before we get too excited about lunar towns and space tourism, there are questions that need answers. Who owns it? Current treaties say no one, but if countries and private companies start setting up shop, those rules could go out the window. And what happens if mining operations damage the environment? It's not like we can fix it later. As it becomes the next big thing, the lines between exploration and exploitation are starting to blur. Are we looking at the dawn of a spacefaring civilization, or is this just the latest gold rush? The truth probably lies somewhere in the middle. Mining helium-3 and rare metals could unlock futuristic technologies, but it also raises ethical and environmental questions. What's clear is that it isn't just a dead rock. It's a treasure chest waiting to be cracked open. Whether we use its resources responsibly or turn it into another cautionary tale remains to be seen. But one thing's for sure. NASA and other space agencies aren't showing us the whole picture just yet. And as missions ramp up, don't be surprised if more secrets come tumbling out of those lunar craters. Imagine this. Earth is running out of rare metals, the kind that power our phones, electric cars and satellites. And guess who has most of it? China. They've cornered the market, holding nearly 1/3 of the planet's stash and supplying over 95% of it worldwide. That's a monopoly so tight, it might as well have a lock and key. Digging these metals out of the ground here on Earth is a nightmare. Pollution, destroyed ecosystems, and human costs that nobody really wants to think about. Yet, we keep demanding more, especially as electric cars take over. The question now is, where do we find the next big supply? Here's where it gets dicey. Mining operations need water, not for drinking, but to make rocket fuel by splitting water into hydrogen and oxygen. Water ice has been spotted at the poles, locked away in shadowed craters that never see sunlight. But getting to it is a nightmare. The environment is hostile. Temperatures swing from scorching hot to freezing cold, and the ground is covered in razor-sharp dust called regolith. This dust sticks to everything, tears up spacesuits, and could even short-circuit electronics. During Apollo missions, astronauts reported it clinging to their gear like glitter that never goes away. And that's not even the worst of it. The poles have a strange electric field. Solar winds bombarding the surface create static charges that can build up to thousands of volts. Imagine setting foot in one of those craters and getting zapped by invisible lightning. That's not sci-fi, it's science fact. Engineers are scrambling to design spacesuits that can handle this, but solutions aren't ready yet. Until they are, exploring these areas is like walking through a live wire. But wait, there's more. NASA's big plan to explore the poles just hit a wall. Their Viper mission, a rover designed to hunt for water ice, was supposed to launch in 2023. Delays pushed it to 2025 and then, boom, cancelled. Millions of dollars and years of research down the drain. Without Viper, the hunt for water ice is stuck in limbo, leaving other countries to race ahead. India, Russia, and private companies like SpaceX are eyeing the prize, ready to pounce while NASA lags. Mining could solve Earth's resource crisis, but it's not as simple as loading up rockets and hauling stuff back. The challenges are massive. Deadly dust, extreme temperatures, and unpredictable electric fields. And the legal chaos? That's a ticking time bomb. Countries are already testing boundaries, and the first one to plant a flag, or a drill, might set off an international scramble. The search for lunar water reveals unexpected challenges. While scientists and engineers wrestle with these hurdles, private companies are racing to make space mining a reality. Firms are designing robots that could operate remotely, scooping up minerals and even building structures without humans ever setting foot there. Norway's intention is working on tech that lets astronauts control machines with simple hand gestures. Imagine commanding a robot to dig for water while you watch safely from inside a lunar base. But there's still one problem we can't ignore. What if mining unleashes something we're not ready for? Think about it. We barely understand the geology. Digging into those ancient rocks could stir up forces we can't predict. Magnetic fields, hidden lava tubes, or who knows what else. And let's not even get started on the conspiracy theories. Alien bases, secret experiments, and lost civilizations. Far-fetched? Maybe. But history has a funny way of turning myths into facts. For now, we're stuck watching the pieces move. China's building a space station. The US is rebooting its missions. Private companies are raising billions, and all of them are eyeing it like prospectors chasing gold. It's a space race, but instead of flags, the prize is control. control of resources, technology, and maybe even the future of humanity. South Korea launched a probe called Danuri back in August 2022. It took nearly 5 months to get there, but by December it was circling like a hawk. What's interesting is that NASA worked hand in hand with South Korea on this mission, sharing resources, tech, and scientific advice. In exchange, South Korea let NASA attach a fancy camera called shadow cam to the probe. Sounds pretty straightforward, right? Well, not so fast. Shadow cam is no ordinary camera. It's 200 times more sensitive than regular lunar cameras, which means it can see that are usually pitch black, like craters at the poles. And one of the first places it looked was Shackleton Crater. Think of Shackleton like one of those dark corners in your attic where you're sure something creepy is hiding. But here's the kicker: there was no ice. That's bizarre because scientists were pretty sure there'd be ice in these shadowy craters. After all, earlier data from India's Chandrayaan-1 mission suggested there was frozen water up there, but Shackleton turned out to be dry. Instead, it had rocky bumps and even a trail left by a boulder that rolled down the slope ages ago, probably older than human civilization. So what gives? Why is it acting like a desert when it's supposed to have hidden ice? NASA's shadowcam kept looking, scanning more craters, but the results were the same. No ice, no frost, not even a frozen puddle. And just when things couldn't get stranger, India's Chandrayaan-3 mission added even more twists to the story. Launched in July 2023, Chandrayaan-3 made history as the first mission to land near the South Pole. It had a rover called Pragyan and a lander named Vikram, and together they started poking around for signs of water. Expectations were high. After all, Chandrayaan-1 had already hinted at water being there, but once again, it refused to cooperate. Pragyan's instruments scanned the soil looking for hydrogen, which is a key ingredient in water. Instead, it found a bunch of metals: aluminum, iron, titanium, and even sulfur, which suggested volcanic activity in the past. But hydrogen? Nowhere to be found, not even a trace. And remember, this rover wasn't built to last forever. It had only 2 weeks before the freezing lunar night would shut it down for good. While the rover was busy scanning the ground, the Vikram lander was measuring temperatures. It found something shocking. Just a few inches under the surface, temperatures dropped from a scorching 50 degrees Celsius to a freezing -10. That's a massive drop, which means the soil acts like an insulator, trapping heat at the top while keeping the lower layers icy cold. Could this mean the water is buried deeper than we thought? Maybe. But the mystery doesn't end there. Pragyan's short-lived journey raised even more questions when it avoided not one, but 2 craters. The first was spotted early enough to steer clear, but the second one, we still don't have pictures of it. And given that the rover's instruments didn't find ice anywhere nearby, it's starting to look like any water that's up there is playing an elaborate game of hide and seek. This leaves us with a big problem. If it doesn't have surface ice, then what about all the plans to build bases there? Water isn't just important for drinking, it's also needed to make rocket fuel. Without it, setting up camp gets a whole lot trickier. And that's probably why NASA and other space agencies aren't shouting about this discovery from the rooftops. It's bad news for anyone dreaming of colonizing it anytime soon, but let's not lose hope just yet. Vikram's temperature readings suggest water might be trapped under the surface, possibly mixed into the soil. And while Chandrayaan-3 didn't find any hydrogen, that doesn't mean it's not there. It might just be harder to detect, especially if it's bonded to minerals instead of sitting around as ice. What if lunar water isn't a resource to exploit, but a clue to an ancient cosmic mystery? Share your thoughts below and don't forget to like and subscribe for more.